about the coordinate plane and graphing. The coordinate plane and graphing. Just go a little smaller. Yeah, this is the coordinate plane, I guess. Coordinate plane, P-L-A-N-E. Right. And really, this is kind of helpful because, you know, back in the day when you used to look at a map, they would have all these sort of things on maps. But even now with our modern technology, you know, the way that cell phones are tracked and how they can figure out where you're at based on your cell phone is all based on this kind of graphing kind of thing, and coordinates that they find by whatever they call ping and all that stuff. So it does have its application. Another thing I always say when we talk about coordinate graphing, you know, if you were stuck out in the middle of the ocean, you know, and you were stranded at sea, how would you ever tell somebody where you're at? Because you can't tell them that you're in the middle of the ocean because the ocean is billions and billions of square miles or whatever it is, and you can't say I'm next to that big rock because there is no big rock there. You can't say I'm under the big cloud that has the whatever on it because, you know, how do people tell where their coordinates are on the ocean? Okay. Longitude and latitude, which is really nothing more than one gigantic coordinate plane wrapped around the Earth. Latitude lines. Longitude goes this way, doesn't it? Latitude goes this way?
Latitude,
yeah. Latitude goes the equator way and longitude goes the other way. So it's good to know this just because it has its applications there. And how you tell where your location is by what we call an ordered pair. And this is not the first time that we've done this. It's called an ordered pair because there are two things and they have to be in the right order. For example, this one right here, 3, 2. It has to be in that order. It needs to be in parentheses. The first number in your ordered pair is what we call the X number, and the second number is the Y number. And when you have both of those numbers together, it's the place where those two lines meet. For example, here's my x-axis and here's my y-axis. If I find 3 on my x-axis, it is this line that's right here. Here is 3 on my x-axis. If I find 2 on my y-axis, it is right here and it stands for this entire line. Okay, but when I put those two numbers together, it's an ordered pair, and the place where those two lines cross is the point that I'm looking for. So just like the Earth is covered with all these lines, latitude, longitude, and they're split up, I mean, you can get exact, precise locations by giving those exact dimensions, except their numbers are a lot more complicated because it's not just one digit, it's like a string of 6 because you cut it into smaller and smaller pieces. What I see most often happen, people getting these wrong, is they flip these around. You know, they put 2, they go 3 on the y-axis and 2 on the x, and they get it completely backwards. So it's all about taking a little bit of time here to do this. It's good to know the point right in the middle there, right there it says right there, is the origin. If someone asks you for the origin of something there, it is that point 0, 0. It's where the x and the y axes axi both meet. This thing, by the way, this whole thing here is called the Cartesian coordinate system. Why it's called that, I don't know. Cartesian coordinate system. My things went right in half of the time there. In addition to that, maybe we can blow this up a little bit here. I don't know if you'll need to know this today or whenever. It doesn't like that spot there. If you look at a Cartesian coordinate system and you look at the x and y axis, it is split into what we call 4 quadrants. You've got this quarter right here, and then you've got this quarter right here, and you've got this quarter down here. I should go with a different color. Go yellow. I like yellow. And you've got this quarter over here. How about a little purple? Okay. separated into four parts, separated by the x and the y-axis, and they are labeled like this. Quadrant number 1 is this one. And we use our handy dandy Roman numerals for that, I don't know why. And then it goes counterclockwise. This is quadrant number 2, quadrant number 3, and quadrant number 4 is an I with a V. Quadrant number 4. And I believe this is probably the first time that we've added negative numbers in with your graphing. Did we do negative number graphing last year?
No.
So that'll be kind of something new for you. If you're looking for the point -3, -2, again, notice you go find -3 on the x-axis. I'm sorry, +2 on the y-axis, and it ends up crossing right there. Same thing here, -3, -2, still the same -3x value, but it's now -2y, goes there, and then +3, -2 over there. When you come up, it's getting kind of messy, isn't it? You know, when they ask you to graph things for your homework, people, I don't expect you just to throw things out there in the middle of nowhere. Your homework paper is divided into little squares, those you will use, and you'll put the numbers on those squares. You don't draw your own squares, you use the little lines that are on your homework paper. You can draw it and put that stuff right there and use that there, or there's extra graph paper back there that you can use as well. Take a look at page 364, would you please, in your books? Just to make sure we're all on the same page there, number 1 says, what are the coordinates of point A? And if you look at point A, it is, looks like it's right here, this point right here. What are the coordinates of that point right there? And if you get things wrong, use it because you don't put them in the right order. Grace, it would be
3, 1.
Yep, 3, 1, because it's over 3, up 1, or 3 on the axis, 1 on the y-axis. How about problem number 2? What point is at the coordinates -1, 3? -1, 3. Which point is at the coordinates -1, 3? Isabel?
C.
C is correct. Number 3, what is the coordinates of point E? Point E is right here. What are the coordinates of point E? Jill?
-3, -1.
-3, -1. Number 4, what point has the coordinates 1, -3? 1, -3. Danny?
D.
D is not. D is -3, 1. 1 on the x-axis, -3 on the y. Which point is that one? One on the x-axis, -3 on the y. That is -1 on the x-axis, 3 on the y. I want +1, -3, isn't it? All right, +1, -3.
D.
No. Are you looking at my graph up here? +1, -3.
G.
There, oh gee. How about point D? What's its coordinates? Aubrey? D is which coordinates?
-3, 1.
-3, 1. And number 6, what has the coordinates of 3, -1? Jenna?
C.
Let her, what? 3, -1? +3, -1. The answer is, gonna look up here, +3, -1 on that graph there. What point is? What's that?
H.
H is correct. Now, I'm gonna give you this piece of paper here. You probably need your protractor or straight edge to do this with. Look at number 7. Look at number 7 on page 365. I want you to take a second and draw the rectangle that it tells you with those vertices. Draw the rectangle and then you have your straight edge for a reason. Draw that rectangle. Draw that rectangle. Give you a little bit of time to do that. You should be just about done with that. You got a rectangle drawn? Coordinates look like this. What was it? -2, -1, correct? The other point was 2, -1. 2, 3, and 2, 3, and -2, 3. And you took your nice little straight edge here and you drew some nice lines. So yours looks a little like, oh, that's not very close. About that. About that. About that. We'll blow this up a little bit and move those. So your rectangle should have looked like this. Is it a rectangle or is it a square?
It's full.
Oh, look at that, it is both. Guess I can't get that there. This should be here, right? Alright, and then we need to answer the questions there. It said to give, the book says to give both the perimeter first or the area first? Perimeter. Here's where you need to be very careful. What is the perimeter of this square? Okay, please count not the lines, because if you count the lines, you're going to end up with 1, 2, 3, 4, 5, and this is not 5 wide. Count the spaces between. How many units? 1, 2, 3, 4. It's 4 units here. 1, 2, 3, 4 units there. 4 units there. 4 units there. So the perimeter is, Riley, 16. The area would be 4 times 4, which is 16 as well. And that's square units. You count those all up there. 16 units squared. That's good. Now, I'm going to do the other one there. What I do have for you to do, did I toss this paper in again?